Madeleine is currently completing her Master's of Science at the University of BC, and she grew up in Invermere and has spent most of her life working and recreating in the Columbia Valley and nearby national parks. As an avid trail runner, backcountry skier, and climber with a keen interest in conservation, Madeleine's passion for understanding the recreational impacts on sensitive alpine ecosystems and wildlife inspired her research. She aims to enhance our understanding of how increased recreation affects mountain goats in Banff and Yoho National Parks and beyond. So without further ado, please join me in welcoming Madeleine, and she will be up on the screen in just a moment. But she can hear you.
Hi everyone, and good evening. Thanks so much for coming. Today I'm going to talk a bit about my thesis work, which I'm actually finishing up in the next month here. But I'm studying the impacts of recreation on mountain goats in Banff and Yoho National Parks. I just want to start things off by saying how grateful I am to have had the opportunity to conduct my research and to have spent so much time working and recreating within Banff and Yoho. The area within the boundaries of these parks has been important for many Indigenous peoples long before the establishment of the parks. This includes the Blackfoot, the Stoney Nakoda, the Ktunaxa, the Secwepemc, the Tsuut'ina, and the Cree. Visitation to parks and protected areas has been increasing globally, and Banff and Yoho are no exception to this. As you can see here by some stats from the last fiscal, Banff saw roughly 4 million visitors, while Yoho saw over 600,000. Although enjoyment and engagement in these areas is important for their continued conservation, land managers are finding it increasingly difficult to balance providing a high-quality visitor experience and allowing folks to recreate without jeopardizing ecological integrity of these areas. Part of monitoring this ecological integrity is understanding how wildlife are being affected. Wildlife have been shown to respond to humans in a variety of ways, which are well framed by these three concepts. The first is landscape of fear, where wildlife see humans as a threat similar to or greater than that of their natural predators. Under this scenario, you might expect to see wildlife being displaced from suitable habitat, shifting their activity patterns, and increased vigilance behavior, which can result in decreased foraging time and in turn reduce fitness and health. The second is habituation, where wildlife have become desensitized to humans after being exposed to predictable, consistent use over time. Under this scenario, you might expect to see a rather neutral response to humans. For example, the bear is casually grazing on the side of the 93 South Highway in busy traffic. The third is the human shield, which is usually associated with prey species, and it's when prey have recognized that their predators are more sensitive to humans than they are, and have used this as a strategy to avoid predation. Under this scenario, prey tend to seek out high human use areas to stay safe from predators. For example, maybe the Bighorn sheep in the town of Radium. Sometimes we can tell how an animal is feeling by its overt behavior or response. For example, this deer on the left. As the hiker approaches, it looks scared and vigilant and might even run away. Other times, an animal might feel stressed, but it may not look like it is if the cost of vigilant or being displaced from suitable habitat is greater than the cost of feeling stressed. This deer on the right might be a good example of that scenario. In other words, behavioral signs of stress are not always representative of physiological stress. An important aspect of an animal's stress response is a hormone called cortisol. Although cortisol is an essential component of an animal's flight or fight response, long-term release of this hormone under conditions of chronic stress can have negative impacts on animal health and reproductive success. The way animals respond to human disturbance can vary greatly between species and even within species, but my focus is mountain goats. So why mountain goats? Well, of course they're the coolest ungulate, but they are also an iconic alpine species that inhabit the mountainous regions of western North America. Here in BC, we have over 50% of the global mountain goat population, while roughly 4% occur in Alberta, and they are found throughout Canada's mountain national parks. Mountain goats are generalist herbivores, meaning they eat a variety of different vegetation types, and they live primarily in alpine and subalpine zones. Mountain goats have a high affinity to escape terrain, which is a critical component of mountain goat habitat. Escape terrain is steep, rugged features that mountain goats can climb to avoid predators, like in this video on the right. On the other hand, denser trees may be associated with higher predation risk. Mountain goats tend to avoid treed areas as the cover can allow predators to sneak up on them. Mountain goats are currently globally listed as a species of least concern, but are listed as a species of special concern in BC. And the most recent management plan for both Banff and Yoho have identified goats as a focal conservation species. And this is because goats are sensitive to the effects of climate change, making them an indicator of the health of alpine ecosystems. Furthermore, goats are sensitive to human disturbance relative to other ungulates, and recently, park managers have become more concerned about the effects of high visitation and recreation on local goat herds. Although recreation has been identified as a potentially significant threat within the literature, the impacts of recreation are still not understood and seem to be variable and context dependent. For example, a study on goats in Jasper National Park found that goats avoided the local ski area despite there being suitable habitat within the boundary. On the opposite end of the spectrum, in Glacier National Park, Montana, mountain goats are attracted to humans as a source of salt from sweat and urine, and have used high human use areas as a refuge from predators. Which brings me to my primary research question, which is what is the impacts of recreation on goats in Banff and Yoho National Parks? Although the populations of goats in these parks are currently believed to be stable, we don't really know what high-impact visitation is having on local goat herds. My research is broken down into two separate chapters that I'm going to combine together today. The first chapter focuses on the behavioral responses of goats to recreation, and the second chapter examines the physiological effects of recreation on goats. The behavioral chapter is framed by three main hypotheses, each related to space and time. The first hypothesis is related to the landscape of fear, and predicts that goats see humans as a threat and avoid humans in space or time to minimize overlapping with them. Under this scenario, we might expect to see that goats are more active off-trail when humans are more active on-trail. Additionally, goats may become more nocturnal to further avoid peak human activity times. As for space, we might expect to see goats avoiding humans in high human use areas, and furthermore, if goats see humans as a threat, they may avoid dense trees and seek out escape terrain when there are more humans around. The second hypothesis is related to habituation. This hypothesis predicts that goats are desensitized to humans and do not avoid humans in space or time. Under this scenario, goats may be active on and off trail regardless of when humans are active on trail. Additionally, goats would not shift their natural activity patterns to avoid peak human activity times. As for space, goats would not avoid high human use areas and would not avoid dense trees or seek out escape terrain more when there are more humans around. The third hypothesis is human shield, which predicts that goats increase their spatial activity pattern overlap with humans as a predator avoidance strategy. Under this scenario, you might expect for goats to be more active on trail at times when humans are more active. Additionally, goats might become more active during peak human activity times. Related to space, goats might seek out areas with more people, and if they see humans as a form of protection, they may feel more comfortable spending time further away from or closer to treat areas and further away from escape terrain in the presence of humans. The fourth hypothesis is from the stress chapter, and because the literature suggests that goats may be negatively impacted by recreation, it predicts that goats exposed to recreation pressure are more stressed than goats not exposed to recreation. In other words, goats in high recreation areas have higher concentration or cortisol concentrations than goats in low disturbance areas. To study goat stress and behavior, I used two minimally invasive methods: camera traps and stress hormones in shed goat hair. If you're unfamiliar with camera traps, they're a motion-triggered camera that collect time-stamped image data. And stress hormones can be extracted from a variety of different sample types other than hair, such as blood or feces, and are commonly used to monitor stress in wildlife. I compared two populations of goats exposed to very different levels of recreation. In the human disturbance site, I deployed cameras both on and off trail and collected hair samples across the entire site. I then compared results to a population exposed to minimal human disturbance. As you can see here, where there were no human trails, and again, hair was collected across the entire site. To test the temporal component of my hypotheses, I used activity overlap analysis, and how this works is you use timestamp image data of a species or a subset of a species to build activity curves over time of day. The peaks are when the most images were taken, indicating that an animal was most active, while the troughs represent when an animal was less active or when there were fewer images. For example, the plot on the left shows low human-goat overlap, while the plot on the right shows higher goat and human overlap. I use this to compare goat, human, and predator activity at a few different spatial scales. For the habitat use analysis, I used image data from the camera traps to create variables representing weekly count of goats, predators, and humans. It is important to note that predators were classified as grizzly bears, black bears, wolves, and wolverines, as those were the species detected on the cameras. Furthermore, hiking made up roughly 99% of the recreation within the human disturbance site. I then used maps and satellite data to gather information about the habitat surrounding each camera location, such as the mean tree cover, the distance to escape terrain, the forage, and the distance to the nearest trail. I then combined all of that information together to see which of these variables influence the number of goats detected at the camera each week. For the stress analysis, I kept it quite simple by just comparing the mean stress hormone concentrations in the shed hair collected from each population to see if there was a significant difference. Now on to some results. So we can see here from this plot on the left, at first it looks like goats may be avoiding humans in the human disturbance site, with neither on or off trail activity really overlapping with peak human activity times. However, when we compare the activity of the low disturbance and the high disturbance populations, there was a high degree of overlap between the human disturbance goats, and the human disturbance goats actually overlapped more with humans midday than the low disturbance goats. This somewhat indicated human shield until we compared the predator and goat activity in the human disturbance site, and that found that predators and human activity peaked around midday, which violates the assumptions of the human shield that predators are avoiding humans. Therefore, we settled on the habituation hypothesis, since it seemed like the decline in midday goat activity was likely linked to something like peak daily temperatures rather than human activity. And this is actually more clear when we looked at those low disturbance and high disturbance goats, and we can see a more substantial trough in low disturbance goat activity, which actually aligned with higher maximum temperatures found in the low disturbance site compared with the high disturbance site. Now for the habitat use results, which I'm going to go through step by step. I would just like to clarify when I'm talking about goats here, I'm speaking about the effects of different habitat, human, and predator variables on the count of goats at a site during a week, not at a single point in time. We have an example of goat habitat here. Some escape terrain, maybe some forage, a hiking trail, and maybe some trees. Next, we'll add in some goats. Maybe we have some nursery groups made up of females, kids, and other young goats. Maybe we have some lone individual males, some females, which together make up the overall weekly count. We can see here that they tend to prefer sites closer to escape terrain with more forage. And they don't really seem to care about trails, but they do tend to avoid areas with more trees. Now let's add some predators. And we actually found that the weekly count of predators did not influence the weekly count of goats. So there weren't more or less goats detected when the number of predators at a site changed. Next, we'll add some humans. So here we did find that humans negatively affected the weekly overall count of goats, and particularly the number of solitary goats. However, we saw no influence of humans on the weekly count of nursery groups. So we didn't see more or less nursery groups detected when there were more humans, but we did see fewer solitary goats, which influenced the overall weekly count. We did not find that the weekly count of humans influenced how goats used treed areas, but we did find that goats tended to seek out sites closer to escape terrain when there were more humans. Again, this effect was most evident in solitary goats, but had minimal influence on nursery groups. In summary, we found a mix of results through the behavior analyses. For starters, we did not find any evidence to support the human shield hypothesis. Predators did not seem to temporally avoid humans. We didn't see more goats detected when there were more humans, nor did goats move further from escape terrain or closer to treed areas when there were more people. For the activity analysis, goats did not seem to change their activity patterns in response to recreation, indicating some level of habituation. In contrast, the habitat use analysis lent a mix of support between the landscape of fear and the habituation hypotheses, with solitary goats seeming to be more sensitive to human disturbance, while nursery groups appeared to be least sensitive. Overall, the results are somewhat unclear, which is where the stress analysis comes in. We actually did end up finding higher stress hormone levels in the human disturbance population compared to the low disturbance population, indicating high levels of recreation may be causing elevated stress in the human disturbance goats. However, this only represents a single year of data, which is why I've included that question mark. More sampling will need to be done to see if this trend persists over time and if it can be attributed to recreation pressure. Although only having a single year of data limits inferences we can make, this study does show that shed hair can be used as a non-invasive tool to study stress in mountain goats, which had not previously been used in this context. So what does this all mean? So it does seem like goats are somewhat able to coexist with recreation in Banff and Yoho at this point in time, given that goats did not change their natural dial activity patterns in areas with high recreation pressure, nor did recreation have consistent negative effects on their habitat use. However, we did see elevated stress hormone levels in the human disturbance population, potentially indicating that recreation may be stressing out goats despite the absence of clear behavioral signs of stress. With the growing popularity of outdoor recreation and the impending impacts of climate change on goats, we may see changes in goats' responses to recreation in these areas over time. The establishment of long-term monitoring efforts that incorporate behavior and stress along with population trends will help provide insights into potential mechanisms influencing population changes, allowing better informed management decisions. I think a key takeaway is that wildlife responses to recreation are highly variable and context dependent. Goats around busy, non-motorized recreation but hunting-free areas like Banff and Yoho will likely perceive humans differently than goats in less busy areas where they may associate humans with hunting risk. I think it is important to be mindful of this situation when out recreating in different areas. If you're out scrambling in a remote area where you know there are goats, consider giving them extra space as they may not expect to see humans and may be more stressed than goats in busy areas like Lake Louise would in the same situation. Additionally, if you happen to find yourself between a goat and its escape terrain, try to give it space and allow it to move to where it feels safe. Overall, if you can make your behavior as predictable as possible, for example, staying on established trails, keeping your dog on a leash, or maybe not hiking in the middle of the night, this can allow wildlife to purposefully avoid areas or times of high human activity and thus reducing the chances of potentially stressful encounters. Thanks so much for listening, and I'd be happy to take any questions.
That was so great. Thank you so much, Maddie. Jeremy completed a Master's of Science through the NRES program at the University of Northern BC on the ecological role of mineral licks used by moose, elk, stone sheep, and mountain goats in north central BC. For the past 11 years, he has coordinated the BC Sheep Separation Program, funded primarily through the Habitat Conservation Trust Foundation. The program works with a variety of wildlife conservation groups, farmers, veterinarians, and government staff to mitigate the risk of respiratory disease transmission from domestic sheep to wild sheep across BC. We couldn't have a better guy to talk about sheep, Jeremy Ayotte.
Thanks, Jenna. Okay. Thanks, everybody, for coming, and thanks to the brewery. It's really why my dad and I drove down from Salmon Arm today. Okay, yeah, I'm a consulting biologist at a Salmon Arm. I'm not going to focus a lot on the recreational impacts on bighorn sheep. I'm going to stick to what I know. I know a little bit about recreational impacts on ungulates and sheep, but I'm going to stick with most of my experience in the last bunch of years has been around this disease that's transmitted from domestic sheep to wild sheep. So I'll focus on that. My reference here for the title of the talk is, of course, Maurice Sendak's Where the Wild Things Are, which is an important book growing up. And and I was thinking mostly what I'm talking about is where the wild sheep aren't. And that has to do with this disease from domestic sheep. So Bear with me, I will get to some recreational impacts on sheep towards the end. So, wild sheep in BC, we've got bighorns in the south, thin horns in the north, about twice as many thin horn sheep as bighorn sheep. Thin horns are the white doll sheep and the gray, dark gray stone sheep. This map is actually built from a database that the province keeps. So they've got what they call the Wild Sheep Registry, which is a pretty accurate picture of where we have occupied wild sheep in the province. Not a lot of species have that sort of attention, and I think that's what I reference here in my next slide. It's something about those curly horns. And I just kind of love the connection with the Fibonacci sequence, which is that odd diagram on the right. This relationship between numbers that actually comes out in the growth of ram's horns as well as snail shells. You can see it in a pine cone. You can see it in a wildflower. It's pretty fantastic. And the other obviously amazing thing about sheep is that they live in these rugged wilderness areas. So, you know, I think it's those two unique things about them that really drive a lot of the philanthropy. There's a lot of money that's available to study sheep, to conserve sheep, whether you're a hunter or not. It's just an impressive kind of scenario in wildlife. Yeah, next slide, thanks. So I think Jenna mentioned my master's research was actually on mineral licks, and so I just thought I'd throw some information out there about mineral licks. It's a really interesting thing with these mountain ungulates, mountain goats, mountain sheep. They live on the tops of mountains for the most part, especially in the summer. There's a lot of elements that are deficient in the plants and the forage that they eat, and just in general, animals that are dependent on plants only, all ungulates, dependent on plants, they become deficient in sodium. So as long as they're panting and crying and bleeding, they're losing sodium. They don't get a lot of sodium out of plants. So thus, they become quite dependent on these mineral licks, salt licks. The term salt licks is kind of evolved into more of a mineral lick because there's this recognition that it's not always sodium that's high in these places where these animals go to ingest soil. It can be other elements as well. And a lot of the thinking now in some of my research on this for my master's degree in Prince George showed that there's just this really interesting phenomenon when they're transitioning to spring forage. It's like throwing your horses out on really lush pasture. They actually get an acidic condition in their rumen. So at a really critical time of year when they need to rebuild body mass after a long, hard winter, there's a flush of fresh food available, and their rumen is imbalanced. And so these mineral licks actually serve as kind of a place for self-medication. They're going there to ingest carbonates and clays that help to buffer their rumen pH and help them get through that kind of critical period where they really need to capitalize on that good food. So super interesting. Some of these pictures are from the Tushoti Lakes area and up north. This is where I did my master's degree. And those are stone sheep. The trails down to these licks are like Parks Canada hiking trails. They're so well used for thousands of years. And some of the licks, they actually just, you know, by the mouthful, they've been ingesting soil that's concentrated elements around the roots of trees that are wicking moisture through the soil. So full excavated roots, there's trees falling over, toppled over, where there's just this unique concentration of elements. And then the other places where these kind of dry hoodoos, where they would knock a rock loose and there'd be a kind of a precipitate behind that rock. That was often the carbonates that they were going after. So super interesting. I'm sure they exist in the range of the radium bighorns as well. Quite often, home ranges are centered around some of these mineral licks. So and very strong appetite for both mountain goats and wild sheep to these licks. Yeah, next slide, thanks. So yeah, the focus of a lot of my work the last 12 years is with this separation program has been around this relatively simple little bit of math that domestic sheep and wild sheep don't mix. The idea is this idea of pathogen spillover, where you have a reservoir population with a high pathogen prevalence, domestic sheep. We've bred them to live in these kind of feedlot environments, high densities. We bred them to be able to live with these pathogens. They end up coming into contact with these novel host populations, wild sheep, and the wild sheep die. So we've seen this time and time again. I think there's over 70 peer-reviewed studies, especially mostly out of the States, that show this pattern of contact between domestic sheep and wild sheep results in really high mortality right away, 60 to 90% of the population, all ages, full curl rams, tip over dead, and then years and years of really high lamb mortality. So sometimes it can be a long, long, slow recovery after that. It's complicated. It's simple math, but it's complicated because we can't really tell people what they can and can't grow on their own property. There's we call it the Right to Farm Act, but it's the Farm Practices Act that really keeps a lot of restrictions from coming into play to protect wildlife. And it's also complicated because these are wild animals. Although Madeleine talked about it, that these animals have high fidelity to things like escape terrain, high fidelity to their home range. There is foray behavior outside of that, especially when a population gets to a certain size. We see young rams traveling further afield. The golden herd is actually genetically linked to the radium herd. So this, at one time when there was much more open grassland, we've suppressed fires obviously over the years, so this whole landscape looks different now than it once did, but those golden sheep were once fully connected with the radium sheep. Yeah, so next slide. So we have this issue, we have disease from domestic livestock coming into wild animals. If we turn to kind of the standard veterinarian medicine approach, you can either reduce exposure to the causative agent, so that would be to separate the two related species. And domestic sheep, domestic goats, wild sheep, and mountain goats are all in the Capernae family, so they can all carry the same respiratory pathogens. Or we could try to increase non-specific host resistance, so that would be like improving the nutrition of our wild sheep, or improving the genetics or immunity to the disease. Or we can increase specific host resistance, and that would be like a vaccine. So those are kind of our three options. Vaccines, apparently the microbiologists tell us, are a long ways out. We're a long way from coming up with a vaccine to protect wild sheep from this pathogen carried by domestic sheep. So that really leaves us with the first one, and I think that's what this shows. Reducing the exposure to the causative agent. So that's separating the two species, separating the domestic sheep from their wild cousins. And that was really what spurred the creation of the separation program, and that's our little logo. It started in 2000 with a big die-off in the South Okanagan near Vaso Lake, where there was known contact between the Vaso bighorns and a domestic sheep farm. That's when our program began. And next slide. So back in those days, we did a lot of fencing. We tried to fence the problem out. We created, on the right, that's an 8-foot fence that we actually built just outside of Cranbrook around a big domestic sheep farm. We did double fencing. That's the photo on the left. Because it's nose-to-nose contact, that's how this pathogen's transmitted. It's a lot like COVID. It can carry on a bit of a wind on a droplet, but it doesn't live outside the body for very long. We did some buyouts where we would, in really high-risk areas, we would approach domestic sheep farms and suggest we buy their sheep and maybe replace them with cows. But it was really clear that this was a very piecemeal approach. It was expensive. putting up an 8-foot fence around a big farm. I think that was about $65,000. It wasn't a few years later where they sold all the sheep and just turned to cows. It's not very effective. So luckily, next slide, this guy, Dr. Tom Besser, he's a microbiologist at Washington State University, funded by the Wild Sheep Foundation, which, as I referred to earlier, is an amazing philanthropy organization. Every year they generate about $7 million that goes towards wild sheep conservation and research. Tom Besser and his group of grad students at WSU figured out that it was actually this specific bacteria, Mycoplasma ovi-pneumoniae, that affected the cilia in the trachea of wild sheep, and it basically shut down the ability for those little hairs to cough up mucus and other pathogens. The slide on the right was really pivotal in that it showed days since contact with domestic sheep, the first 10 to 20 days, those lungs of those little baby lambs were full of mycoplasma. And then it was, as that mycoplasma shut down the hair, that first line of defense, then it was all these other pathogens, secondary pathogens that actually caused the pneumonia and end up killing the sheep. So we realized then that if we could target this one particular bacteria, that's a way more effective approach than trying to fence the problem in. Thank you. So being able to test for MOV became a really strong tool. We could do it. It's a PCR test, just like COVID. It's a long nasal swab. We could take it to there's an agriculture lab in Abbotsford that developed the ability to run the test for us. And so our thinking was, great, now we could have potential policy where it could be, it'd be one more of many tests that people need to do for domestic sheep. In the north, where we're way more concerned about this disease in the north because a lot of those sheep just live everywhere above a certain elevation. In the south, we've kind of got these little puddles of sheep here and there. But in the north, we thought we could set up a zone where domestic sheep were just prohibited. There's not a lot of domestic sheep farming up there anyway. And then in the south, where we do have quite a bit of domestic sheep farming, we could just mandate this testing. You can have sheep here, domestic sheep, as long as they don't carry this bacteria. Yeah, next slide. So without policy, this is kind of what we're looking at. This little infographic was developed to help explain a big project I've been working on lately. This is kind of the point of contact where all these little bacteria in the noses of domestic sheep and goats, they touch noses. Often it's a young ram that's maybe traveling up through Edgewater that jumps in with a group of domestic sheep. It can bring that pathogen back to the herd. We see this big drop in the population, this kind of all-age die-off. And then you think, well, you know, at least some are going to survive. Maybe they'll build an immunity to it. But unfortunately, what happens is those surviving ewes end up passing that pathogen, that MOV, onto each crop of lambs, and they don't survive that first summer. So typically what you see is a normal batch of lambs this time of year, and then by the end of summer, when they're weaned off their mother's milk and they're not getting those antibodies, they all die of pneumonia, and you see less than 10 lambs per 100 ewes. That's kind of the threshold. So at the end of the graph there, the red line is kind of what we see with these chronically sick populations, and the green line is what we're trying to do that I'm going to tell you about next when we actually remove those surviving mothers that are chronically shedding the bacteria. Okay, next slide. And that's this Fraser River project that I've spent the last 6 years working on. It's about a 10-year project. This is the biggest group of California bighorn sheep. So I should have mentioned, these are Rocky Mountain bighorn sheep. We've kind of got two subspecies. They're not actually species. They're ecotypes. So there's some differences in body type and a few other things, but for all intents and purposes, they are the same species, bighorn sheep. These California bighorn sheep, this is the biggest population on the Fraser River from Lillooet north to Williams Lake. 1990s, we saw kind of peak levels, and since then we're about 70% less. This project is the first test and remove or test and cull in Canada. It's a tough project. We're killing sheep to save them. So far, we've caught 270 sheep in 8 different population groups up each side of the Fraser River. We found the bacteria in 7 of the 8 populations, and we've killed a total of 38 sheep. The really impressive thing is we've seen the lamb numbers just shoot right up. So before treating, a lot of these populations had 0 lambs, and the average overall from all different groups was 13 lambs per 100 ewes. The last 4 years now, we're seeing up over 40, which is an indication of a fairly thriving population. And it's super complex and expensive. We're flying helicopters around catching sheep. It's about $250,000 a year. The big thing is that, we're improving these bighorn sheep populations in a really important herd in British Columbia. But the other thing is we can go to our politicians and say, we need to manage this issue on farms before it gets on the landscape and into the wildlife, because again, this is not an effective solution. We're not sitting on our hands doing nothing. We're attempting to recover these sheep, and we're kind of using the story to continue to push for policy. So all this is captured on this amazing documentary. I don't know if you've seen it. It features an awesome farmer in Briscoe, Jen Bowes. It's on YouTube. It's won a whole bunch of awards. It's about an hour long. It's all about this stuff. And it was also funded by Habitat Conservation Trust Foundation as well. That's our website. You can find out all you'd like to know about this disease, and you can link to that film on the website. Okay, other terrible things that bighorn sheep have to deal with. So South Okanagan, I was just at a disease meeting there, and all this is kind of, my thoughts were, you know, we recreate the time we like to spend in the mountains, in these wild places. These animals have a lot to deal with outside of all that. So we don't want to be the tipping point. And so that's why I'm going on about this. But Sauroptes is this nasty little bug. It's a type of mange that the South Okanagan, all through Ashnola, on the west side of the Okanagan Valley, are struggling with. It's in their ears. Their ears get all curled up like this. This guy had it really bad, so he's lost a whole bunch of hair. But it's a super tough disease that they're struggling with, and they're trying to get rid of there. It originally came from rabbits. There was a game farm outside of Penticton where they housed bighorn sheep and rabbits, which turns out was a really bad idea. Blue tongue, I'm not sure if you've heard of that, but it kind of swept through on the heat dome summer a few years ago, brought up on a warm wind some midges, little chronomids, little mosquitoes, carried this virus, just decimated the Grand Forks herd of bighorn sheep, as well as a whole bunch of white-tailed deer. The only way to get rid of that is a good frost. So that's the first time it was confirmed, I think, in Canada, and hopefully it'll be the last, but the way the climate's changing, it probably won't. Contagious eczema, I know that's been an issue in the Columbia Trench. It kind of comes and goes, and it's endemic in the population as well. Fire suppression, conifer ingrowth, and cougar predation. So that's a huge problem for bighorn sheep from British Columbia down to New Mexico. We're really good at putting out fires. Unfortunately, that means we got trees growing in places where it always used to be grasslands. These animals have amazing eyesight. They've evolved to live with coursing predators like canines, not so much stalking predators like cougars. So when you do get, and Radium saw it a few years ago, I think there was a dozen or more bighorn sheep killed by a single cougar and her kittens. So this is a big issue that's stacked against them as well. I just got one slide here on the Radium bighorns. I've done some work with Dr. Amélie Mathieu. She's a veterinarian that's worked on the Radium Stoddard herd and discovered this liver fluke. So obviously these bighorn sheep are well urbanized, and Madeleine's presentation explained a lot of this habituation behavior. Quite a few of these sheep have stopped migrating. It's pretty good life on the golf course. Unfortunately, that means they're seeking out different water sources, and I guess that's what's happened. They've headed down to the wetland a few too many times. In the wetland, you've got a bit of a nasty creature living in the grass, life cycles, part of it in a snail. And so I think there was 4 rams out of the Radium bunch that died with, infested with this liver fluke. And that, again, is the first time that's been documented in bighorn sheep. Next slide. So, on a happier note, what can we do? So that's really, the beer is great, but why I came down here today was more, that's part of my job, is this outreach, education, more people that know about this disease issue between domestic sheep and goats and wild sheep, the better. Nobody wants to be responsible for the demise of the local bighorn herd. So it's really just about education. We've had great success working with 4-H groups and kids. It's something they can test for. It's really simple. It's just a nasal swab and you send it off to the lab. The liver fluke issue has so far been resolved. Apparently, Amelie was saying that since they had this alternate water source, that they haven't seen any more mortalities. So that's something we can do. And I think just in general, these species blow me away with just that, the conservation dollars behind them. So the Wild Sheep Society BC and the Wild Sheep Foundation out of the States have done amazing work to keep more sheep on the mountains. Real quick, I guess, recreation impacts. And Madeleine alluded to this. These are, for the most part, cumulative effects. They're little incremental impacts on these sheep that are already dealing with a host of tough issues to be a sheep these days. There are some clearly documented impacts. There's one paper that they actually put, they gave a bunch of backcountry skiers little GPS units. They had a whole bunch of collared sheep. They showed quite clearly that those sheep bailed out of these basins that those skiers were going into. So it's increased vigilance, less time eating, it's range abandonment. Usually if they're leaving a valley, that's the valley they want to be in, so they're going to some less optimal place. But there's simple things we can do, and Madeleine, I'm glad to see we agree. It's quite simple. You just want to avoid that spatial overlap, especially if there's lambing sites. We have a pretty good idea where these sheep go to give birth every spring, which is right around now. We need to avoid those. Obviously, the most vulnerable cohort is those mums that are trying to raise those young babies. And yeah, similar to Madeleine, consistent, predictable behavior. That's the best thing we can do. Walking on a trail at the same time. We really don't want to have an impact on these animals. So let's devise a plan that we can monitor, whether it's trail cameras and camera traps, whether it's a kiosk with something that people fill out. I ran into a grizzly bear. We can track some of those potential impacts, and you can preset corrective actions and say, if there's more than this many, we're going to shut the area down. And that is a really effective thing. You get people around a table talking about not whether or not they're going to have an impact, but they're talking about what are we going to do if we see whatever it is we're monitoring go past these kind of acceptable levels. And I think the other big point too, there is a lack of empirical data for these thresholds. So these are real social decisions. And we got to be okay with that. We're not going to maybe find the paper that supports our hypothesis. We just need to be clear and articulate that we do not want to have these impacts, and this is what we're going to do to monitor and correct it if we do see it. And I think this is my last slide. So far and away the best tool is local stewardship. This image on the right, Jen Bowes, her farm in Briscoe. She bought a wool pellet mill. She pelletizes waste wool. She doesn't like it referred to as waste wool, but a lot of people that raise sheep have to shear their sheep every year. and they throw the sheep in the compost pile or get rid of it. She buys that, she pelletizes it, and it becomes a product for soil amelioration, and it's got nitrogen and holds water. It does great things for soil. The big thing is we've done a whole bunch of work on her farm. She had this MOV bacteria on her farm. She had a lot of trouble with it. She's a fiber farm. She clearly could show that those sheep and that wool was lower grade because of this bacteria. She also did not want to be responsible for any connection with the radium herd and the demise of the radium herd. So we worked with her a lot and covered some of the costs. And so she's now developed this product that she sells, and she kicks back a percentage to the Wild Sheep Society. It's the best thing. And she's made all these contacts with domestic farms because she's a farmer. It builds that peer-to-peer approach. There's confidence, and it's not a confrontational thing that it can be. Her whole program is called Reimagining the Threads That Bind Wildlife Conservation and Farming. Amazing. And I think we could think of the same thing in terms of recreation. We want to be in these places where the wild things are. So big picture, I think healthy recreation is healthy wildlife as well. And I think that might be it. That's it. Yep. Thank you.